For those of you who don't know me, my name is Nick Mooney. I'm the South Island Territory Manager for NZCB. So with great pleasure actually to welcome our next two speakers up on stage. We have the privilege of sharing a shared office space with Bob in Christchurch, and we get to see Dan quite a bit. And to be honest, it's a highlight of the week when we get to see you guys through the building. It's awesome. So just a little bit of an intro. Bob Burnett from Superhome Movement is going to be talking about future-focused design and construction of superhomes and what is the Superhome movement. Bob Burnett has over 30 years of design experience and is an early adapter, advocate and educator of high-performance, sustainable design and construction techniques. He focuses on advancing design, education and reducing the effect of poor housing on the environment and improving the health of our communities while also creating beautiful, livable, lovable, light-filled spaces. You can tell he's an architect. Bob's work regularly receives awards. He was awarded the Sustainability Superstar Award and the Sustainability Business Network Awards. He founded the Superhome Movement Charitable Trust in 2015 and co-founded the QuakeStart rating system after the Canterbury earthquakes. Dan Saunders from Dan Saunders Construction. Dan will be talking, I love this one, super versus stupid, high performance building techniques and associated costs compared to code minimums. Just a little bit about Dan. Dan is a Canterbury builder with over 30 years of hands-on experience in the construction industry, including 20 years of running a small, medium-sized residential construction company. As a New Zealand certified builder, he holds an advanced construction qualification and is also a certified passive house tradesman. Notably, he made history by constructing the first Homestar 8 home in Australasia back in 2012, and his commitment to sustainable housing is evident through his involvement as a founding participant and committee member of the Superhome movement. Over the past 15 years, Dan and his company have completed over 50 high-performance homes, primarily upscale architectural designs. With this strong background and experience, Dan is influencing education through consulting to the Workforce Development Council on integrating sustainable construction methods to further carpentry qualifications. He enjoys lecturing and mentoring carpentry students, sharing his genuine passion for sustainability to influence future generations. Dan's approach is grounded in practicality and a genuine desire to make a positive impact on the environment through his work in the construction field. So without further ado, I'd like to welcome both Dan and Bob up onto the stage, or one after the other maybe. Give them a round of applause, please.
Kia ora koutou, everybody. Thank you, Nick, for that very comprehensive introduction.
Wasn't it?
Yeah. So great to be here. Really great to be talking to a room full of builders. And I think it's the first time I've actually got to speak to a group of builders, but certified builders, no less, the cream of the crop, the best of the best. So I think it's really important that that you guys as builders can have the right conversations with your customers, with your clients, and it's probably one reason that's really important is because a lot of the time the architect isn't involved. And I think Brands did some research a few years ago, only 5% of homes are designed by architects, and the rest, well, most of them, probably 90% of them, are built by group home building companies. So we're going to talk pretty quickly. We've got a lot to cover, and I'm recording this, so I'll be able to share that with you afterwards, so you don't have to remember everything. I can send you the slides too. So yeah, people, some of you guys might have had a big night, so you won't be able to remember everything. You might be a bit dusty on it this morning. I was a good boy and went home early. But yeah, so I think I was counting Greg when he took ECITO, when he talked, he said super 3 times. It could become quite irritating, but I just put super in front of everything, it just works. So yeah, super excited to be here, and it's a super important topic that we're talking about. So yeah, the surprise that someone who counts and tells me how many times and gets it right, how many times I say super. Okay, so I've got some notes here, which is good. So one of the big things that big challenge. There's a number of challenges in there, interrelated challenges that we're facing in the building industry, and it's actually really, really hard keeping up. So we're going to talk. Dan is going to talk mainly about some of the H1 details and how shit they are. So I heard yesterday that Petra we're allowed to swear, which is refreshing. So I promise I won't use the C word, code. But yeah, if I do talk about the code, I'll probably swear afterwards. Yeah. So yeah, it's great to be here. I just want to start by saying we can all have impact. It is hard, and we've got a really steep learning curve to be able to build better homes that are healthier and energy efficient and climate positive. But we're here to help. The Superhome movement is a charitable trust. Everything is free, or as much as possible free. We just want to share information because we think it's such an important thing. So, yeah, code 2 decades behind, probably more. So we're going to time travel. So we're going to take you into the future. And yeah, we've just exited the TARDIS downstairs on the ground floor, and we're now in the future. But wasn't Melissa's talk yesterday quite fascinating, just thinking about where we're going to be heading in the future? Unfortunately, she stole some of my quotes. Luxman's to follow, but had to delete those. But I've still got one. Yeah, so one of my friends who I've worked with in the past, Julie Villard, she's an architect, French architect, and when she came to New Zealand and got a job working with me, she said, I'm from the future. And she saw how we were building in New Zealand and just thought it was like time travel, it was like going back in time. And you know, other people, I've heard people laugh at how we build, and I was chuckling, what's funny? And they say, well, that's how my grandfather used to do it. But it doesn't have to be that way. So we have a saying, KISS, is keep it super simple. It's one more simple. It's better than keep it simple stupid. Yeah. So keep it super simple. So New Zealand, it's slightly less, but globally 39% of carbon emissions come from building and operating buildings. In the future, that's only going to increase, unfortunately, because as we are living in a warming climate, we're going to use more energy to cool our buildings. Even in New Zealand, where we're predominantly a heating climate, that's going to change. By 2040, there's going to be 50% more buildings that are over 25 degrees for 50% of the time. Yeah, 5 to 7 times the carbon emissions that are required to meet our Paris Agreement climate change global goals. That's where the building code sits. It's well off, so we need to do much, much better. The first changes to H1 that we've seen last year, yeah, if you think that's arduous, then that's a walk in the park compared to what's coming. Next year we're going to have to calculate carbon, and I'm just up to my neck in that at the moment. We're working on New Zealand's first carbon negative superhome, and I'm going to show you a couple of case studies and talk about the design. I think that's probably the best way to describe the design. But yeah, before we get into that, just my story is probably the reason why, or probably the main reason why we did the Superhome movement. So back in 2011, my family and I got tipped out of our house after the earthquake. We got to experience substandard rentals, and I had 2 boys, newborn and 3-year-old, and my wife, she's a Japanese architect, Shizuka, and she's the brains of the operation. She's more qualified than me, but so it's a partnership, our business, we work together, and yeah, so I used to call them Japiwis, small Japanese Kiwis, but they're now 13 and 16. I can't call them that anymore. But yeah, so we ended up bouncing around rental accommodation, got took out of our energy efficient near new home that we'd designed ourselves, which was really warm and comfortable. And we moved into one particularly bad house in St Albans in the swamp, came down off the hill into the swamp. And it was fine in the middle of summer when we moved in, but then rising damp in winter, mould, kids got sick, the doctors, trips to the hospital, trips to the doctor. The doctor eventually said, I think it's your house that's making it sick. So the oldest developed asthma, quite serious asthma. That was triggered by the mould in the house. So if I do a renovation and I need to figure out if there's a problem with mould, I'll just take him in there, he's my hypersensitive mould meter. And he'll react to that really badly. So it's a big problem. 30,000 children get admitted to hospital each winter, and it's only growing. You know, I read in the news that's growing year on year. It's a big problem. So we need to renovate our homes as well as build better new homes. And so we'll try and cover that a little bit too. So I'll keep moving because, like I said, we've got a lot to talk about. All right. So you're ready? Buckle in. We're going to the future. So you guys who are building homes, creating homes, we have 196 times the impact, the potential to have impact to what any of us as individuals can do in our own lives, making small changes. So we can have impact, we should, we need to. And that's the good thing. And the good thing is we know how to do everything already. We've got the science, and it's not a technical problem, it's a communication problem. So that's great. All right. So Superhome movement, I sort of covered this a little bit. We're a charitable trust, group of like-minded builders, architects, subbies, suppliers, everybody working together. And I think it is a challenge, but if we all share ideas and work together, it's going to make it easier. You know, we're stronger as a group. And it's super great. It's a partnership with the certified builders too, because yeah, it's just ideal. And you know, I probably should have talked earlier.
Just on that note, we are looking, because we're mainly based in Christchurch, so we need people who are like-minded people around the country to help support the movement as well. So if you're keen on, once you finish this talk, come and see us or get in touch with us. If you're keen to you know, act as a representative or help promote the movement throughout the country, then yeah, get in touch.
Cool, thanks Nick. So just a shout out to our partners, so Christchurch City Council, Brands, JIB, they're long-time supporters, and you know, some of these people have supported some of our initiatives like the Superhome tours that we do. Some of you guys might have heard about that, and design guides. We're just redoing our design guides at the moment. Yeah, so brands have a really good message, by the way, and I think probably part of the problem is they're talking to the industry only, they're not talking to the homeowners. So I think the Superhome movement is unique in that we have a voice and we have outreach with the community, particularly with our tours. Thousands of people come on the tours. And I think that's important because a lot of the time builders and even architects, they know how to do better. They know we should be doing better. But they don't talk about it because they think we're on a tight budget, we can't afford to do that. Building to builder code is really expensive. Dan's going to talk about costs later, the other C word. So I think costs, I think of it in two ways, price and cost. Price is what you pay for something up front, cost is what it costs you over time. We don't think about the second one, we only think about the first one. So 10 principles of Superhome, it's over here. 2, so yeah, that's not all of them, you know, some of them are sort of, there's a bit of cross-pollination there, eh? Some of them are interrelated, but they're just the top 10 hits. And Yeah, and I think, yeah, we're just trying to make things easy. Base, better, best. If you're on a budget, base, the minimum standard that we think is a healthy home, and climate positive home. Still much better than building code, but much more affordable than best. Best might be in terms of thermal performance, passive house, that sort of thing. And then, yeah, free certification. Not thousands of dollars, free. Might be a bit of an admin cost, but we're just trying to share ideas. Okay, modelling. How many people do energy modelling now? 1, 2, 3.
3 down the back.
4.
Yeah.
Okay, it's coming. So that'll be building consent compliance. You'll have to model things in the future, but I've been doing it for 20 years, and I started doing it by using an add-on for ArchiCAD, the CAD program we use, and that gave us energy analysis. Now it's built into the program, so there's no excuses. Everybody can learn how to do that. So I was just interested to know about the energy efficiency, so that's why I did that. It's usually, if people are doing it, the few people that are doing it, it's usually done at the wrong time. It's usually done at the end of the project and for accreditation or ratings. It should be done at the concept stage so that you can adjust the design if you need to. Energy modelling doesn't design it for you. It tells you how good or how bad it is. So it's not a silver bullet. You've still got to know how to design it. But it's an important tool if it's used at the right point. So we're taking a different path with Superhome. We're monitoring all superhomes. I can't show you, I've got an app on my phone, but it's over there. But yeah, so I have all the homes, they're like my children. I can just see what the temperature is, what the CO2 is, what the humidity is, and then we can match that up with the energy used, and we immediately know the performance of the homes. $200 those sensors cost. That's all, not thousands of dollars to predict the performance. That's the proof is in the pudding. That's the actual performance. And our dream is to have that on our website and have it real-time data so you can see how the homes are performing. So that's where we're heading with that. Big step, and I think a great initiative. Once again, keep it super simple. Dan?
Yeah, thanks, Bob. So every year we have tours. Basically, it's an open home where the public and industry, or whoever wants to, who's interested to see what it feels like to be in a super home. We usually do it around winter, so you can get the true benefit of what it's like to be, in a thermally efficient home. People can hear directly from the homeowners and the subcontractors, because it's a bit like the conference here where we've got the suppliers. They can talk about their product and the benefits of using them and things like that. So it's unique because it has a wide community outreach. We have a lot of people. I think last year or the year before we had about 5,000 people through over the weekend through half a dozen houses in Christchurch. So it does have a good public following in Christchurch. And again, like I said earlier, if we have people across the country, we can organise, facilitate that across the country. So that's pretty good. We also have a bus tour, so an industry bus tour. That's again, we go down and see either the same houses or different houses that people only want people in for, say, 45 minutes. We have a wee look around and again talk about the benefits and the products and systems that are included in these homes. So that's
probably a great one for industry folks, because it's a bit more in depth and you get like topics at each house, and it's not just about the learnings, and it's also about the connections that are made. So the thing that I found with Superhome movement, I met Dan. He was probably the first builder to join Superhome, and I've got to know who the best builders are, and the builders get to know who the best designers are, and who has the best products. So that's a big part.
So as you can see on the date there, the next one in Christchurch is the 6th of September. The open homes in Christchurch, the date is the 20th of July. So that's next month. Any builders in Christchurch that are keen to get on board, just jump on the website and you'll see the link to join up.
Actually, we get people fly from all over, from Auckland, from Invercargill, from Wellington, to come and do the tours. Yeah, cool. So, yeah, this is one of my quotes that I think Melissa stole. Yeah. Anyway, this is so true. And I think, let's just, if you're going to remember one thing, anything, don't trust the building code. Let's just make the existing model obsolete by creating a new, not fighting the existing reality. Yeah. So the other one, I'm going to talk about design over these case studies. The other one was when working, Buckminster Fuller. He's an architect, he's a visionary, he's a great writer too, but quite more of it in the detail. But the other one, when I talk about design, it's like Buckminster Fuller. When working on a problem, I never think about beauty. I only think about solving a problem. But when I've finished, if it's not beautiful, then I know it's wrong. I always think about beauty, and if it's not beautiful, it's not finished. Okay, so there's many parts to a super home, any home, and we need to think about homes as a system. And one of the flaws of the building code is it's very piecemeal, and they've tinkered with the insulation values of certain things. They didn't touch the walls. Crazy. They've said let's have the windows, much better performing windows, but you can still install them in the cold cladding cavity. So I think about systems, not just solar systems and heating systems and ventilation systems. I think about the whole building as a system and how everything works together, how the wall joins to the window, how the wall joins to the floor, to the roof. It's a system. And we need to employ systems thinking where we're joining the dots. So this is a little house which, I'll just brush over this because we just run out of time. I think there's so many things to talk about. But this house, designed to passive house, low energy building. It's 34 square metres, and so you can see there's a big wall that goes through the middle that hides a lot of the plant, the ventilation system and things. You've got the bedrooms on one side, and you've got the public area, the open plan kitchen, dining, living on the other side. This house, last time I met this client, he said he had a $260 power bill credit on his power, so he's in $260 in credit. And I heard from him recently, he said he had a $168 power bill for the year, the whole year. It's $168. There's 18 solar panels on this house. If there was like one or two more, then it would be energy positive. It would have no power bill at all. That's not just the house. This is in Prebbleton, which is, 20 k's out of Christchurch. He runs, they have an electric car which goes to Christchurch. So it's almost energy positive for the car and the house. It can be done. They love their house too, so that's one of the houses that's going to be on the tour, the one that was in the picture. So you can see this big wall, there's cross ventilation, it's got these clerestory windows, you can open them up and get a delightful breeze going through there. That is airtight, but it doesn't have to always be airtight. You can open the windows. People like a breeze sometimes, it's pleasant. So that's the ventilation system I was talking about, and that's just an overview of looking at where it is. It sort of sticks out like the proverbial amongst all the houses that all look the same in this subdivision. But you'll learn more about that if you come on tour. And also our website has some videos of the owners talking about their houses. So these two houses were the first super homes in New Zealand, and they're actually the first 10 Homestar rated homes in New Zealand. And that's where it all started. The first tour had these homes on it. One was our office, the two-story one at the back. We moved out of that building and sold it to some people. There's people now living in it. It sold for about 20% more than we were expecting. And everybody who was at the auction wanting to buy that house, they were acutely aware of the sustainability and energy efficiency attributes of the home. So if you do put, say, 5% more into the build, do a better performing home, high performance home, you're building equity in it anyway. You only get that if you sell it, but it's good to know that you're doing the right thing. If you build to code, then maybe you're at risk because your house isn't going to be worth as much. This project here is the one that I briefly mentioned. This is Nafare Parada, which means to warm oneself or bask in the sun. So this is New Zealand's first carbon negative super home. Well, there's 4 homes, townhouses. They're all separated to allow a beautiful quality of light and sun into each of these homes. I think that's really the number one principle of architecture. Humans like sun. Your typical property developer would fill up the gaps here and do 7 homes, not 4. But we're thinking about people and livability. People before profit.
Health and wealth.
Health before wealth. He's got all the puns. So these are some of the homes and some of the interiors, and that's on the website too if you want to have a look at it. So we're partnering with VQuest. They have an app which is linked to ArchiCAD. I think it links to other programs as well. So they're calculating cost, carbon, weight. So yeah, we're just fully into this at the moment and learning about this, and there's a lot to learn. But it's fascinating. So that hopefully is going to help us automate the process, but we've still got to work out, get all the data for all the materials. By the way, if you're a product supplier, you need an EPD, because by next year, everybody's going to ask for an EPD, and if they can't get it, they're going to choose a different product. So EPD stands for Environmental Product Declaration, and it will tell you how much carbon, embodied carbon, is in the product. So, just before I get to this, I forgot, I'm full of statistics, I forgot a couple here. I'm full of them. Yeah, so when I was talking about my kids and the health issues that they encountered, yeah, there's 1,600 more people die in winter in New Zealand. It's called excess winter mortality. Other countries don't have that, or have that in much less numbers. There's really sound research that's been done on health and the impact that our buildings have on people's health. For every Dr. Philippa Howden Chapman, and it's 10 years ago, maybe not quite. It's a long time ago. Widely known accepted research. It has led to zero change. So every $1 spent on warm, healthy homes, warm, dry, healthy homes, it saves $4 for our public health system. But that's the government. But it'll also save money, and if kids off school, sick, parents need to be off work looking after them. Productivity is down. It's a big problem, and we don't think about it enough. So, quiz, just before I hand over to Stan, which one of these people has the most impact on our health, public health? There's no Lego architect, so I had to Photoshop the black turtleneck and the little round glasses. But you can see the other two. A lot of people, I've got a thing here. A lot of people would say this guy here. Hands up. A. Wrong. Only 5% of architects. Only 5% of homes are designed by architects. Hands up. B. That's more like it. Someone's saying the hands went up. That's cheating. Hands up. C. Okay. C is only treating the symptoms. The ambulance at the bottom of the cliff. Builders. You as builders have the most impact on public health.
Right, so what we're just discussing is this is a project we've got down in Geraldine. Some of the costs that I'm going to give to you guys is relating to this project, and also reference our home as well. So we've been in our place since 2019. It's a 1974 typical 3-bedroom, 1-bathroom, on piles, no insulation in the walls. It had been retrofitted with from timber windows to timber single glazed to double glazed, just normal aluminium, so not thermally broken. So I'll reference that. So that's this house here has 167 metre squared floor plan and 98 square metres of insulated wall exterior. So just a quick show of hands. So who here is incorporating energy efficiency into their builds now? Okay, cool. So I see by the room's pretty full, so I understand that everyone is interest. That's why you're here. Who fully insulates their slabs all the time? Nice. And who recesses their windows all the time? So what we'd like to see is reasons why we're here is to get those numbers up and work through the reasons why. So foundations. Do you want to chat about what
Oh yeah, so H1 changes came in and there was like 28 pages of tables in there about slab insulation. All completely useless to our crew because they're all below where we're at. So we're already doing much better than those changes. They're just the first baby steps. I think, to be honest, I think it's too little too late. But we actually struggled to show compliance without going off on energy modelling because they changed the way to model slabs from 2D to 3D. So, but we found this free tool, Waffles 25 Firth, who introduced that to us. So they make that freely available. Waffle Suite. Go to Waffle Suite if you want to work out your slab R value. And yeah, so that's kind of saved our bacon there. We knew that it was going to comply, we just needed to show the council.
Cool. So as you can see here, this is the reason why we need to fully insulate the slab. So this is a new house that it's got slab insulation underneath, but the edge was retrofitted. So this is all the energy escaping the house before someone's moved in. So once someone's moved in, there's going to be a lot more energy in there and heat moving to the outside. And that's what's happened. That's showing it once it's been insulated. So you can see straight away it works.
Yeah, but what percentage of heat loss is it? Nobody's been able to explain to me what percentage of heat loss comes out of the house. I mean, we're talking about a distance of 225 from the top plate down to the bare ground level.
Yeah.
Yep.
Can you tell me what percentage of heat loss is actually lost out of that?
In terms of the floor, it's 80%. So what you do,
80% of
what you do under the slab has a lot less impact than what you do at the edge. 80% of the floor.
Look, I've been in this industry for over 40 years, and that concrete slab, when it's cured, that temperature doesn't change once it's cured.
Well, yeah, I can tell you it doesn't in the South Island, where it's really based.
You know, the cost to actually implement all that is just a massive cost on the building.
Okay, I'm hearing it. Dan's going to talk about cost.
Yeah.
We're jumping ahead. Dan, couple of
Guys, if we can keep the questions to the end, I'll run a microphone around.
Yeah. So obviously that's one of the reasons why we fully insulate the slab. So our default is usually a 50 mil EPS VH grade under the floor, fully under the floor, not just the ribs, and up the side. So we can change that to suit the design parameters of the house or what's needed. Obviously when you're doing underfloor heating, you need a little bit more as well with the new changes. So we've got, we do different types. So we've got, so we have a standard rib raft. We've got topping, what we call a European topping slab. So these particular builds that we've got here, we needed specific engineering design for that one there being up on a hill and bed into rock, and that one there is on TC3 land in Christchurch with floodplain requirements, so we had to engineer quite how high off the ground. And for in order us to have a fully insulated slab, we would have had to do quite high insulation on that side there. So what we've done is done 50 mil EPS, or 70 mil actually in that case there, and 50 mil XPS on the side. So that is fully isolated and thermally broken from the foundations on the outside, and the same with that one. That one's there is this level here on that house.
So I think, just sorry Dan, the key thing with this is you don't want starters going through that slab from the foundation. Sometimes people don't do the topping slab, they just do one slab and there's a break, and there's your starters at 600 centres, whatever. You know, if you've got steel rods, steel is 54 times the conductivity of concrete. So if you 12 times or 10 times 54, that's 500. It's almost like taking away all the insulation. So yeah, steel's bad. So avoid the steel with the stopping slab. It's the way the Europeans do it.
So also when we've got another project, then we also had floodplain requirements as well as very, very soft ground. So this was a triple T foundations, basically call it power poles in the lattice formation underneath. So and from there we've got mass timber CLT with a once you get the underfloor heating and then a topping slab on top of that. So that gives us that thermal mass in the concrete and also allows us to run the underfloor heating.
Bit of a breakthrough, because before that we didn't think we could do a heated concrete slab on soft ground, so that was good. We've done several projects since like that.
Yeah. So obviously there's a lot of proprietary systems out there now that give you a full product like the Allied one out there. The other option is obviously to do it yourselves and using EPS or XPS and then plastering the edge of it. So,
Are they German piles?
sorry?
Are they German piles?
No, they're not.
No.
No. They're just like I say, if you imagine a sheet of trellis, obviously the ground underneath's been engineered, because if we went to a riprap slab, we would have had to dig down like about 2 metres, and then you have a problem with sorry Bob, shoot in the face, shoring up the outside, because it was basically shoehorning a house into a very, very tight site. So there's a lot of external issues around that. So we
So raft is a good, triple T raft is a good way of describing it. So you've got like poles crisscrossing perpendicular. The thing that saved is a shitload of steel and concrete, because that house too needed to be net 900 out of the ground because it's in a flood management area. So a lot less embodied carbon than doing it that way.
Sorry, right, so the question is, what does it cost? So based on that house at the start, I've done some pretty rudimentary sums based on your buy cost off your merchant portal, and EPS using a 30mm EPS at an R value of 1.1 is $1,300 for materials. So I'm just leaving labour out just to give you an idea on material cost. Using 50mm EPS, again VHR 1.39 at $2,100, and then if you went up to PIR, 50mm PIR, you've got an R rating of 2.5 at $8,500. So obviously there's quite a jump up there for performance. But then if you did a hybrid version where you've got 50mm EPS underneath the slab and 50mm PIR on the side at 2.5, it's costing you $2,800. So if you're adding that into the overall cost of the project, it is a very small percentage. So just moving quickly onto walls. So with the walls, NZ3604 is currently doing a review, and it's going to be talking about looking at thermal efficiency and thermal bridging. So that's good to be seeing that happen.
I don't know, but hopefully they go to 140 framing, because it solves a myriad of issues doing 140 framing.
Yeah. So with foundation, there's obviously different types of systems that you can use to get a high performance wall. So there's straw, ICF polyblock, thermomass concrete, conventional SIPs, which is either EPS or PIR. We tend to use a prefabricated panel, just basically timber frame on steroids. So it comes fully external cavity to surface cavity, and it's got airtight layers and it's fully insulated when it comes to site. So that's our go-to. That's fine. Oh, so with these walls, so NZ3604, a lot of you are probably aware that I think it's clause 8.5.4 with lateral support with dwangs. People are still doing dwangs, and as you can see, placemakers are offering a dwangless system. The lateral support is either, and the key word here is either using a RAB or your conventional dwangs. So a lot of the houses that are being built now, regardless of whether they're super homes or not, is you're liking seeing an IBS product or a plywood product getting fully wrapped. So there's your lateral support, lose the dwangs, foot insulation, full height, and that makes thermal efficiency so much better. What we have here is another thing with conventional timber framing is the old triple stud corners. I'm guilty of, I've done it before, especially in the apprenticeship years. But you don't know what you don't know. I haven't done these corners for about at least 15 years. So conventional if we look at up the top there, we've got either a jib fix, or another term for it is the California corner. It allows insulation to run through and losing the areas, or covering areas where it's blocked out by the extra stud there. So what happens is, most of the time the house gets wrapped and those areas there don't get insulated. Oh no, it's fine. So if you're just watching here this animation, that's where the energy's going through. If we take those studs out, obviously we're getting a timber saving, a cost saving with the system. And by losing obviously the dwellings and the timber framing, you get to put the insulation running full all the way through, and you get better performance.
So incidentally, the first house in Christchurch to have this system, it wasn't called Jib Fix, it was called Frame Saver, was the 10-star home that I showed you, the very first super home. And I thought this would just become the new normal, because insulation is much cheaper than timber, and it's more thermally efficient, but we've just carried on doing it the same way, until Placemakers just recently introduced this frameology. But a lot of people put it on their drawings, and then it doesn't turn up to site that way. So you've got to really check and make sure that you talk to your supplier, because they, until now, they've preferred to go with the apology afterwards and say, yeah, sorry about that.
Sorry.
But yeah, so you've really got to talk to people. If you're doing anything new, just talk to people. Don't expect them to just read the drawings.
Oops. So just going, and you're saying, right, so we don't have any dwellings, so what are we going to do with our horizontal cavity batten when we're using vertical cladding? So ideally we always use a 45mm structural cavity batten, so that allows it to pass from stud to stud, and then you're fixing your cladding to that. And the other thing that it also doesn't do is penetrate your weather tight membrane. So again, that's just mitigating potential risks later on. So from the inside, having a surface cavity on the inside here, it allows us to, again, the insulation to run full height, so it's uninterrupted, and it gives us a chance to put airtight layers, which we'll briefly touch on later on. And basically what it means is all your services, electrical and plumbing, will run in this surface cavity here, which then gets insulated afterwards. If you look at most of the plans that you'd probably see, or predominantly where you have your ensuite in the master bedroom and your ensuite next to it, the ensuite's in the external corner, your shower, your tiled shower or showers on the external corner, the plumber goes and puts his pipes, his mixers in, and then your insulation installer comes in and tries to cut the insulation around your mixers, which is obviously creating a weak point for thermal loss. So there's good. Yeah, keep going, keep moving. There's also on the outsulation, so there's products out there like timber fibre board, rock wool, which can be also installed on the outside of your envelope as well to get rid of that thermal bridging. Let's rip through this. So also when you're talking about thermal bridging, we have where the steel goes. We try and avoid using steel where we can, because engineered timber now has come in leaps and bounds since for a wee while, so it spans a lot further. Where you do have to put structural steel in, like a portal in this area here, it was put in within the surface cavity, so it's inside the thermal envelope. We don't have thermal bridging.
Cool.
Did you know?
So this is the other thing shown in this slide. There's an external blind on this, and whoops, Casey. Yeah. So this house here doesn't have the external blinds, but we're doing some projects now that we're using these. They attach to the windows. Once the sun has hit the glass, the horse is bolted. You either have external shading, like this house has really good, huge overhangs. It has these shading elements. It's got this little eyebrow at the mid-floor, which is often missing in a two-story house. So none of that uses any steel, by the way. It's all just plywood both sides. So this is one of my colleagues' neighbours. He lives in this building, and his neighbour has tinfoil on his window because it gets too hot. Brand new house, built to the New Zealand building code. So I think I mentioned we're living in a warming climate. We've got to start thinking about overheating because the buildings that we built today will be around for not just 50 years like the building code suggests, 100 years hopefully. That's what we hope. Cool. That brings us segues into Windows. So Windows, super important. We building code detail on the left. Obviously, that looks familiar to a lot of people. For 10 years, we've been recessing the windows, UPVC. They're more expensive than aluminium windows. So aluminium window thermally broken will be just about as good, but if you recess it, it's going to be much better than this puppy here. And you've got this big warm support bar. If you have your windows supported on the frame, you don't need that big chunk of aluminium, which is basically a big super highway for thermal bridging. And so you can get rid of that and save some embodied carbon in the process. And so no more weeping windows. So there's a lot of things to think about with windows. Aesthetics, buildability, Dan will talk about that. Weather tightness, air tightness. How airtight is the window? Anything if it's more airtight, whether it's the window, the whole house, if the whole house is, or the wall, the whole house, the building's more airtight, it might be twice as good as a building with the same R value, construction R value that's not airtight. So it makes a massive difference. So it's probably the single biggest thing you can do to save energy is to stop the heat leaking out of the building. It's not all about insulation only. So, there's a lot to think about. And even before you start thinking about this stuff, technically, how good your window is. What are the size and proportion? What's the orientation, the design? You could get away with, did I just say that? Get away with less performing windows if you've designed it well in the first place. A poorly designed building might need triple glazing, whereas a well-designed building might only need double glazing. Super versus stupid, there you go, I said it. So that's the jam there, and so when we recess the windows, it's kind of like there's as many details as there are different claddings to a degree, but I know even our mainstream aluminium suppliers have got recessed window details now, which is really great to see. Building code still has the windows out in the cold, bonkers. You're actually throwing your money away if you're spending more money on high-performing windows and you're putting them in the cold cladding cavity. We need to stop doing that. Probably the biggest thing you can do is, there's a lot of things to think about with windows. We've done a whole kind of seminar on windows. It's online on our website, hopefully. So that was the last one. We're doing monthly seminars on different topics. The next one's on ventilation. If you do an airtight house, you need ventilation. So we don't have time to go into that, but if you register for the webinar, you can find out about that. Probably the biggest thing is the glazing, the biggest performance uplift per cost. If you do low E glazing, that's going to be money well spent. So we're going to do 0.5 now. I mean, the best windows are approaching R2. So these products are available now. So the other thing is, we talked about shading. Man, there's lots to think about, isn't there? Earthquake resistant. So, in the earthquake social buildings where the windows bubbled, it was incredible. The main thing that happened is they separated at the corners. Maybe we should be allowing a bit more tolerance when we're installing windows. Speaking of installing windows, and I don't know if we're the only country, but probably, where everybody's still pre-measuring, site measuring before you make the windows. You can just order the windows before and save some time. We don't need to measure every window and make it. Just on the earthquake resilience, it actually doesn't cost much more a lot of the time to reach 150 to 200% of new building standard. It's just about getting your window proportions in your solid wall and your environmental bracing, structural bracing in the home. So another thing to consider. So there's a lot of things you can do with shading. There's a little eyebrow there. that's actually my own house on the left. You know, we put these RHS frames, and my idea there was, hadn't quite finished this yet, but to put some solar panels on there, 6 solar panels. The solar panels on the roof, but I'm going to put some extra ones on there, and that's going to create the shading for that upper room. So you can do cool sort of dual purpose things like that. Dan?
Sort of flying through. So roofs, go back a step here. Obviously we've got different options the way that the roof has to, or the ceiling insulation has to be. For me, having a weak point here of a 500mm piece of insulation where the rest is double, I mean all the warm energy is coming up here to the outside part and going up here. If you raise your heel of your roof, or even extend your eaves, or extend the truss.
Would you call that stupid? Dan?
I would.
Yeah. That's the wall is where, that's the weak point, that's where you're going to have the heat loss. There might be a window in that wall. If you remove half the insulation there, completely bonkers. Someone at MD tried to tell me that doesn't make much difference. I call BS on that.
Yeah, so there you can double it up just by raising the heel, which will give you some extra some height there. Or having a surface cavity, which we do for ventilation, so you can also insulate that. So then, if you're just keeping a normal standard heel height, then you're getting your double insulation there, plus a little bit more, which is not touching the underlay up here.
You might not need all of that. You might not need that cavity under the truss to be insulated. Or if you do it that way, you might not need the bit on top. Because I don't actually think, you know, or particularly north of Christchurch, I don't think you need a 6.6. If you energy model the building and you have good windows, good walls, good floor, you can get away with less in the roof.
So another option is a warm roof. Here we have a 90mm PIR across the whole. It's sitting on top of CL mass timber here, so there's about 166mm of timber there. Then we have our PIR on top. On top of that we have our roofing underlay counterbattens, which are 20mm, which allows ventilation through. Then our purlins sit on top, and then roofing on top of that. So just going back quickly to this here. Oops. Technical difficulties. The reason why we're doing this is we are 20 years behind European countries when it comes to insulation values. There was a brand study done in Build 181 in 2019 where they measured Dunedin or compared Dunedin and Dublin. They're on the same latitude, but Dublin is over twice in some areas our insulation levels. Obviously that's changed a little bit now since the upgrade in H1 to the roof, but that's what we're up against. So.
Just on, you know, that's just one thing that's missing that's not right in the building, but I mean, like I already mentioned, they did nothing for the walls. But I mean, what's the point in having a really warm roof if you've still, you know, having a beanie, if you're still in your singlet and your jandals? You know, you've got to do the whole house. And you know, the other things that are missing from the building code: no ventilation requirement, or open windows, it doesn't work. No air tightness requirement. There's actually no heating requirement. So Healthy Home Act, Healthy Home regulations, they now require a rental property, an existing property, to have better heating than a new house. Go figure. There's so many things that are missing and wrong with the building code. Like I said, if you don't remember one thing, just get over it. We can't trust it.
Well, there's a saying that gets bandied around a little bit. Building code, it's the worst house you're legally allowed to build.
Yeah, but the trouble with that is we use it as the target, the industry, the mainstream industry, not you good people, but it's seen as it should be the floor, it should be the minimum, but it's actually the ceiling. And that's why we're doing the Superhome movement. We're trying to create awareness about this. Okay, so opportunities to get involved in the Superhome movement, just really improve your brand and your recognition. You know, the Superhome of the month, every month we have a newsletter, sign up for that. Superhome of the year. First time we've introduced it this February for the first time. It's, you know, we got national media coverage with that, so it's another opportunity to get involved in that. Yeah, we're just trying to shout from the rooftops about how people can create a better home to create a better life for themselves. So, guys, if you want to get involved in this, email us, info@Superhome. If you email me, I can send you the recording. And so there's also an opportunity to profile yourself alongside the Superhome design guide and contribute to that, if you can't do that. What makes a Superhome? The people, super designer, super builder, super consultants, and just working together and from an early stage. These are some of the events we got. I'm aware we're running short of time. We might open it up for questions. And yeah, or James, you want to talk about the sort of early?
If you do want to, we're flying out later on this evening, so we're floating around the rest of the conference. So we'll hang out around here at the end of this if you want to have some more conversations. I do have some other figures that I didn't get a chance to run through, but come and see us. But if you've got any questions now.
Got time for a couple quick questions. Yeah, I've got save me running. You have to talk very, very loudly. No questions? No worries.
Just quickly, one thing you need to mention is actually this is good for your business.
It is very good for your business.
Yeah, so you guys think about getting into this. It's actually good for your business. People are looking for it.
So if you can educate yourself and be confident in what you can deliver, because most of our work, people are coming to us because we are leading in the field. Things are changing. It's not a matter of will they change, it's a matter of when they change. If there's probably seen the bell curve where you have early adopters, the masses, and then the laggards at the back. Don't be laggards. Find out and upskill as much as you can, especially now things are a little bit quiet on the front. So I suggest you upskill yourself and be in front of the. We can only build so many houses a year. There's 40,000 consents being issued every year. We can't build them all, so what we want to do is make sure as many as possible are built to a standard that's much better than the code.
Thank you very much.
Okay. I'm going to throw another super in there, super passionate. If there's one way to describe these guys, that would be the way I would sum them up with the dealings that I've had with them during the time. So again, thank you very, very much to Bob and Dan for coming and talking about this. This isn't going anywhere in regards, this is only going to get, as they said, more and more in your daily barrow. So really urge you to reach out to these guys and utilise the skill sets that they actually bring to NZCB and offer to our members. So again, a round of applause for both Bob and Dan. And if anyone's sticking around, I think the next session starts at 12:05. But we will need to just scan everyone in for that one as well. Get your LBP points while you can, eh?